Yes, hello everyone. Good evening, Saul. Um,
Good evening.
at our first creation report. So, what is it about? Basically, I think that I have been very rarely hosting shows at my channel, at my YouTube channel, and there is so many things that we can share, and I'm restricting myself to Facebook and so on. And I think um, it's important that we share what we are learning on a daily basis, and also what we see that atheist channels claim, and then we can talk about it and eventually provide our perspective about these things. So I actually prepared an introduction PowerPoint here in regards of the topic tonight, which is about if DNA stores instructional information. But I'm not able to actually visualize it. So I'll just check out while we are here having a conversation if I can set it up. So, Sal, let me ask you, what do you think? Does DNA store instructional information in the sense that it instructs to do things?
It stores some instructional information in the development of an organism. According to the central dogma of molecular biology, it gives specifications, parts of the DNA, and I emphasize only parts. In eukaryotes, it's maybe, for like a human, it's only about 2% that specify specifically the sequences for the proteins. There are other parts of DNA that do other things than providing instructions. There is so minimally, yes, it does provide some set of instructions for creating proteins. That's a very well accepted dogma by independently described by Francis Crick and James Watson. Now, I will point out, Emery Moyna and I had a discussion on cortical inheritance, and I showed that there is a lot of instructions in the construction of an organism, particularly eukaryotes, that is totally outside the DNA. And it is still very hard to experimentally show these aspects and really have a handle on it, but we know it's there. We know it's there because of some of our experiments. We know if we break certain things, it just doesn't rebuild. So I know that was a long answer to your question. DNA holds instructions for building certain parts of
Yeah, sometimes when
the
I
cell.
when I mentioned this speed, he said, "Oh, but it's just an 1.5 or 2%." So, if we are making a calculation that the human genome has about 3 billion nucleotides, so 1.5%, that would be about 45 to 50 million nucleotides. That is already a huge amount of information, isn't it, Sal?
That is a huge amount. And now we can actually go through various calculations. If we assume that 3 billion or 3.3 gigabases or whatever the number is, the current number is, that equates to 6.6 gigabits of Shannon information. If we only assume 1% is coding for anything, that would be like, what, 8 megabytes? So you could do the math, you divide, you take 1% of 6.6 gigabits, you divide by 8, you'll eventually end up to be about 8 megabytes. Does anyone seriously think 8 megabytes is sufficient to make something as complicated as a human being, or let's say even parts of a human being, like say the immune system or the brain? And so let's go to the higher figure of 10%. Do you think 80 megabytes is going to be enough? That's just a rhetorical question I keep putting forward. And I'm just like, guys, do you realize how complex a human being is? Do you really think 80 megabytes is enough to do the job and to do it really well? And that actually led to my exploration of cortical inheritance, because if we even think that do I have my cell phone here? Okay, I don't have it handy. But you think about a cell phone that has maybe 3 gigabytes of RAM. Or do you think that a human being could be coded with 800 megabytes? I mean, my cell phone has at least three times as much memory. Do you think that's enough? And so I said, okay, the information to construct a human being is distributed. It's distributed in the glycome. It's distributed in the organelles. There are all sorts of instructional manuals there that we're only touching upon, and we're stumbling on it. It's just, and I specifically asked when I was at class in the National Institutes of Health, studying chromatin modifications. And I was looking at these pictures of mouse embryos. I don't know if I might be able to show it briefly.
Yeah.
I'm going to scramble to get it if you wanted to say a few words while I grab it.
No, feel free. No, I think if we consider that the human body has about 37 trillion cells, so does the position of each single cell not have to be instructed somehow? And if we have let's suppose that even the 3 billion nucleotides would be instructional, how would that be sufficient to instruct the position of all these 37 trillion cells? So I think this alone, this figure alone, is already evidence that there has to be more epigenetic information which is in play in order to construct organismal complexity. And as you said, the glycome is the glycan code on the surface of the membrane of cells. That's already a far bigger sized information content just there. And I have collected over 41 different epigenetic codes and languages, and they are all involved in information sharing and organismal building. So, I mean, it is obvious that genetic information alone is not sufficient, but there has to be much more epigenetic information involved.
So I was taking a class on chromatin modifications, which we sometimes call epigenetic. That word is abused a lot, so I I may avoid using it. But let me try to explain what this picture is. This is a picture of a mouse embryo at various stages in time. So this is like 3 hours, 8 hours, longer. So A, B, C, D, E. Now, unfortunately, F, G, H, I, J are just controls. So just ignore that. It took me a while to figure out that diagram. So we could see how this embryo, on the top is the paternal DNA, on the bottom is the maternal DNA. So this would be the DNA from the sperm of the dad and the DNA from the ovum egg of the mother. But now it is joined together in the embryo. After 8 hours, you could see that the lighting indicates the number of methylation marks on the DNA. So it's being flipped on, and it's being even more DNA is being flipped on. But then look at panel C. Even beyond 8 hours, at some point the paternal DNA's, all the methylation marks are erased. The epigenetic marks are just like rebooted. And
Wow.
I asked my professor, I said, how does the cell know to do that? Where is that information stored? If you think about it, no one's ever answered the question, okay, how do you know that, like, say at 16 hours, you're going to start to reformat? Where is that information stored? Where does it say that on the DNA? Okay, let's erase the methylation marks. So there's more instructions in the process of development than we currently know where it resides. The professor, who was a postdoctoral fellow, a very bright researcher, she said, well, actually posed the question to two of the professors. One of them was actually a pioneer of the histone code. So I was really privileged to be in that class. And he said, no one knows. And then I asked a similar question to his postdoc, who was also co-teaching the class. He said, oh, the cells are very smart. she was just smiling. It's like, well, she basically said no one knows, but the cell is very smart. It has a lot of the instructions. So that's all to emphasize. Um, all these attempts to trivialize what the cell does, I just think it's kind of ridiculous, because the people that actually study this. Oh, by the way, so let's just complete the picture here. This is now when we first have the first mitosis. Now that the embryo splits into two, and then it eventually becomes four, and you can see the changes in the methylation states. I have another. They're even better graphs now that show the histones in all sorts of colors. You could actually see the cells differentiating, even when you had the first, say, 16 or 32 cells. You could actually see the different markings on each of them. Even at that stage, they have different epigenetic states, and they can colorize it. And I keep asking the question, where is the information stored that decides when and where that these changes happen? No one has an answer to that. No one. And
I asked when I
no one
was
knows
when I
where
was
that
in
is.
Seattle, I asked Richard Sternberg about this, and he said the same thing. We have no clue where this epigenetic information is stored. So this is you said some time ago that science is now in a evolutionary stage, let's say, where they are starting to tackling and exploring and unraveling these questions, where this information actually is stored. So I think that, I mean, the paradigm shift has already happened. Even if we advance understanding and knowing where this information is stored, what this already means is that the quantity of information in organisms to make multicellular organisms is far bigger than just genomic information. And then you have to ask yourself, can that be the product of undirected evolutionary mechanisms? And I think the answer to this question is a clear no. That has to be pre-programmed information. Would you agree with that, Sal?
We got cut off briefly, but when you're talking about we're beginning to see, yes, I would agree. We're happening upon it. And one thing that we'll hear from cell biologists, the evolutionary biologists will say that biology's junk and clumsy. The famous words by Charles Darwin about the devil's chaplain on the blundering things in nature. You don't hear that from the people that actually study at the cellular and molecular level. Rarely. There are a few like Larry Moran, but many of them will say words like exquisite, innovative, artful, masterful, clever, crafty. And you're just like, yeah, they'll say everything except intelligently designed, but those words are often pretty good. Now, what this picture was, it's similar to the one I showed earlier. Now, this is a picture of C. elegans, a worm. And again, this is the embryonic development. This is at 2 cells, 4 cells, etc. And what they're highlighting with the colors here, that's the lineage that will lead to the gametes. So even at some point, unfortunately, if you could see it here in panel F, you could see the 2 red dots there with the little blue surrounding it. Even at that stage, the reason they're different colors is the histone modifications are different on the cells. Those histone modifications identify the cells, even in the embryo, that are going to become the gametes. They're going to be involved in gametes and reproduction. So even at that stage, it's already anticipating the next generation in terms of reproduction, and it's identifying the cells. So all these cells are unique and they're modified. They may have the same, by and large, the same identical DNA, but they have totally different epigenetic marks. And that's what I like about pictures like this. You could actually see what the epigenetic changes are, and they're different between the cells. So even though in general, approximately, we could say that all 1 trillion cells in a human being, or 100 trillion or 50 trillion, whatever the number is, they may have essentially one genome. That's not exactly correct, but it's close. But they have 100 trillion epigenomes. 100 trillion epigenomes. Every cell has a different epigenome than another.
Wow.
Where's the information that creates this? How does this decompress? Where is it stored? No one knows. And so when I hear speed of sound just trying to trivialize the DNA by saying it's only 2%, I'm like, DNA isn't everything. And this is proof that it's not everything, because somewhere this information has to be stored, and there's a lot of it. You need information to store 100 trillion epigenomes and to express it. So, I just don't buy it. That biology's trivial. That's just ridiculous.
Crazy. Would you say, Sal, that each single cell, therefore, has a very specific proprietary epigenome, which is different from the neighboring cell, even if the cell type is the same?
Yes. Now, it might be hard to establish that for the whole body, for, say, a human, but it is accepted fact for all the brain cells. Every neuron cell is different. And if you think about it, that makes sense. How does a computer work? When it stores information, it has to put it in a specific address and then retrieve it from a specific address. Every address has to be unique. In a comparable way, when the brain is storing information, not just like learning, give it a very simple example. When you hear someone's voice and you recognize it, so you're learning to hear someone's voice, and you don't even realize that your brain is storing this away and it's retrieving it. It's doing pattern matching. Same for smells, same for tastes. There's a lot of learning that's going on. It has to address the right brain cells in the right location to grab it. And part of that is differentiation among the cells. We still don't know how this is exactly done. And it's done on several levels. First off, in the chromatin is likely changed between each of the cells. There are slight differences based on the line 1 transposons. It creates slight changes in the actual genome. It transposes pieces of the genome so that each genome is actually a little bit different between cells. This was established in the Mayo Clinic and the Howard Hughes Medical Institute. They said, oh my, there's what they call mosaicism in the brain cells, in the neural cells. But who knows what else is going on? I actually, when I was studying neuroscience, I saw how there is alternative splicing and alternative splicing that was marking little pieces of the neuron in the receptors of the neurons. My jaw was dropping. I said, there's so many things that are slightly different that are just so finely organized. And it has to coordinate all these connections. The human brain has more connections than all the switches and routers of the World Wide Web. It's just phenomenal. The numbers are astronomical.
I hear that it has more switches than the number of stars in the universe.
I've not heard that number, but it's a big number. Being able to manage that amount of distributed processing is just insane. And there are probably levels of its operation that are beyond anything we can comprehend. So I saw Gart said, who's saying biology is trivial? Well, I had a quote in mind. Let me see. Maybe it's not exactly those words, but it's the sentiment of some people. There was it's called Darwin's famous quote on the Devil's Chaplain. I'm sorry, you're just seeing me. Just Google it here.
No problem.
My internet is really slow. I'm going to stop sharing my screen, and maybe when I find it, I'll just read the quote.
Okay.
So,
yeah, I mean, I tried to find out how many different neuron cells there are, and science has no clue about that. have they advanced somehow in responding that question?
I've heard a number of 100 billion in the central nervous system, and the
No,
numbers
no,
fluctuated between 80 billion or
no,
whatever.
no, I'm not asking the total number of neurons. I am asking about the different kind of neurons. Does science has an answer today about how many different ones there are?
There are major families of them. There could be many. I mean, I just remembered they summarized it on the page for the neuron classes, but maybe there are very many more than I saw, but we had to at least study the very basic ones. Like a really basic one would be just like in the retina. That's a very specialized optical. And then you can imagine then something for the ear or something related to smell. But then there are all sorts of these special ones in the brain. And my jaw dropped when I saw all the different cell types. The amazing thing is all these different cell types come from the same embryo. Just remarkable.
Yeah. Yeah. I mean, I ask myself, how can just one stem cell differentiate 37 trillion cells and knowing exactly where they have to be located in the human body? That's just crazy, you know?
Right. And it goes beyond that. Think about the process of healing. When I worked briefly in the nanomolecular science group of the think tank I used to work for, MITRE, I mean, just really passing, but I was very fascinated by the work. At their big annual meeting, they said, okay, the two biggest problems we are dealing with in building nano machines is how to make them self-assembling and self-healing. And I was like, yeah, self-healing is a pretty big problem. I mean, just imagine having a computer and it gets broken and it self-heals. The human body is able to do that with cuts. So that means there's some sort of distributed processing, like in Bitcoin. If you damage parts of the Bitcoin network, it's able to reconstitute. It's still able to hold together. There is some serious technology there in being able to coordinate so many cells that they could affect self-healing. And so it's more than just ordinary development from one point. It's developing from one point and then overcoming all these obstacles of damage and then varying environments and nutrition. So yeah, how does it do it? That's still an unsolved problem in human engineering. How do we make self-healing machines? The reason that's important is there's a lot of thermal noise and quantum noise. When you start to get into molecules, self-repair actually has to be very significant. That's why we have self-repair in DNA. There's a lot of spontaneous chemical reactions that when you deal with very small systems that you don't worry about in like larger scale systems like a regular computer, you get down to where individual molecules become critical. Self-repair becomes very important. We don't know how to build anything near like what biology can do with self-repair.
Yeah, that is really awe-inspiring. And as I said in some streams, that I am studying the ribosome and discovering that during the biogenesis process of the ribosome, that it goes through test drives or it is checking if the individual proteins and ribosomal RNAs, if they are properly folded or not, and if they are working or not. I mean, this is just awe-inspiring. I mean, we know that like if you have a factory and you make a car, then you have to check if the individual parts, if they are properly built. And of course, this is an intelligently designed process with the goal to have a functional end product. And seeing that in the ribosome, that's just amazing. It is not only during the ribosomal translation process that there are several different error check and repair mechanisms inbuilt, but also during the construction of the ribosome, the cell knows when the individual parts are correctly synthesized and when not. And when they are not correctly synthesized, then the proteasome discards these strands and recycles it. And if that is not there right from the start, then these misfolded and wrong proteins or ribosomal RNA strands, they would accumulate in the cell and then probably kill the cell. So this is an all or nothing situation. Either you have all this kind of error check and repair mechanisms built in right from the start, or you will not have life.
I found the quote. I'd like to share it. So this is a sentiment of many evolutionary biologists. It says, "What a book, a devil's chaplain." By the way, a devil's chaplain was Robert Taylor. He was a rogue minister who was atheist. He would be like an anti-theist today, but he was just really crazy. So devil's chaplain refers to someone who is very anti-Christian. He was an ex-minister. So Darwin said, "What a book a devil's chaplain might write on the clumsy, wasteful, blundering, low, and horridly cruel works of nature." So he didn't, that is one viewpoint. Since the fall, there are lots of cruel things happening in nature, and there are a lot of things broken. We see sickness, abundance, but yet we see incredible levels of sophistication and intelligent design at kind of the Christian viewpoint, that we were intelligently designed, but also subject to a curse. So that sentiment was carried by Jerry Coyne. His book, Why Evolution is True, a lot of the arguments I've been hearing are these bad design arguments, like you saying the inverted retina and all. And I'm just like, it just gave it a little time. And the physicists were saying, oh no, this is a great design feature, this inverted retina. And I talked to an electrical engineer, and he was just like, wow, it does that. And he's an antenna engineer, and he does a lot of stuff with electromagnetism. When he saw how this was put together, he said, that's incredible. He said, I work with these waveguides, and we have these optical waveguides inside the eye. He said, in the designs that he's approving and working with, he said, these things have to be so precise. He said, you can't be off. It's not going to guide the wave. You need to have a really good engineer to build this. And so I just hear that at every level, especially the cell biologist. And the funny thing is, the people joining the fray now are the biophysicists. They're the ones that understand the engineering. And I wanted to say one other thing about error correction, because some evolutionary biologists or evolutionary leaning, they're saying, oh, what an incompetent designer that he would have to make something that needs error correction. He would get it right the first time. And I'm like, no. There is a reason that we have the Shannon theorem. There's a consequence of Shannon's theorem of communication. Everyone quotes Shannon because he had the major breakthrough in communication. He realized that the best way to have a communication system that can pack as much, say, quote unquote, bandwidth, the proper term is channel capacity. Meaning, if you want to put as many bits as possible on a disk, if you want to pump through as many bits through a wire, the best way to do it is not to have perfect signals. It's to have signals that have slight errors because of the noise, and then to correct it on the fly afterward. So your compact disk has Reed-Solomon error correction, both in the read and write. And when biologists were telling me the designer's incompetent because he had to put error correction to put errors, I'm like, no, you guys do not understand communication theory. Any electrical engineer that works with communication will recognize that this is genius. This is the way to do it. If you want to compress as much information in the tiniest space possible with the least amount of energy and matter, you use error correction. So the thing is, they're viewing this from a philosophical standpoint. They're not viewing it from an engineering utilitarian standpoint. When you look at it that way, it begins to make sense, and that's when you start to see the genius.
Yeah, I mean, as I said previously, unless you have all these error check and repair mechanisms right from the start, you cannot have life.
Exactly. Well, I didn't have anything else. I guess we're still kind of figuring out what we're going to do with these shows. I will say, if you're not aware, there's a I'll try to keep tabs on your channel for your events. We have a public channel, a public calendar that lists all the events that Standing for Truth, Logical, Plausible, Probable, the Evidence Reason channels, which are mine, and then I'll put you on the calendar. Today was a packed day. There were at least 6 events. So after this, there's going to be Kent Hovind on modern day debate, and then an hour later, Standing for Truth with Snake was right or something. So it's a packed day.
Yes. I would be interested to have something on a daily basis, but I'm not sure yet if that will work. It depends also on people actually joining and willing to have and share these topics and discuss them. So it doesn't depend only on me, but it can be at your channel, it can be at mine, or we can figure that out what would be best. What we are seeing is that there are so many atheist channels out there and providing misinformation, and I think it is important that we are putting out what we believe and justify our reasons to believe.
Dr. Carter said he'd be interested in helping us whenever he could. So that'd be great, even if we only get him every other week or so, just to have him join us. I would be, it'd be helpful for me to work with you on your channel. It's difficult for me to do live streams. Like I mentioned this to you in backstage, but I'll mention it for the viewers. One reason I do recorded shows a lot is because of my mom's condition. When we were recording the biotic message, I had to pause the recording for 20 minutes while I took care of mom. But for the viewer standpoint, it seemed like one continuous show. And so I'd be happy to drop in occasionally. Like I'll try to at least come by once or twice a week to your show.
Yeah, I invited Lena too, and she said she would join us, and she's all around. I think the most difficult part for a new channel, my channel is not so new anymore, but in order to have something, let's say, more frequently, we need to have at least a few people which are willing to join and start these conversations, and then I think from there on it will be easier to have people starting to know about the channel and willing to join and have these conversations.
Well, what I was going to suggest is maybe if you had a topic, you can have a show, and then I could come and bring a topic, one that I did a little research, and then we could talk about it. Because I find all these either even at least some of the abstracts of some of these original papers, or even in the popular press, they're interesting things. There's also things about, I wanted to have a talk on the peer-reviewed process in certain areas of academia. And it's not directly related to science, but it should be eye-opening with what goes on. Because if academia is letting certain disciplines get away with the kind of nonsense they have with peer review, they ought to let some of the discussions we have also get in university. That's never going to happen. It might, but we'll see. So what I was going to suggest is I'll try to, if this is a good time, I'll try to schedule a couple shows to drop in. If for some reason I get called away, you'll have to take over the rest of the conversation. But I do want to support your channel. And Gart says, I'm a major authority on peer review from working at the NIH. I think a lot of the science peer review is good. It's other disciplines like, say, social science that I just wanted to highlight. So I think very highly of the NIH. I think very highly of the peer review that goes on in chemistry. It's excellent. But I just wanted to I made a comment just before my channel got scratched by YouTube before they reinstated it. They scratched it. They said this is scam. This is misleading information.
Did they say that?
Yeah, that they sent me a nasty letter after I had my 3 chemistry lectures and 1 molecular biology lecture. And
oh, wow.
yeah, I put it up. I put the whole ordeal up on my channel, and I said, well, in in certain universities, and I was specifically talking about Duke University.
I'm shocked, Sal. I mean, that's censoring. They are censoring content because they are disagreeing with what we believe. Wow.
Yeah, I mean, they're messed up. What's really scary is what happened to David Woods, Act 17 Apologetics. He has 500,000 subscribers, and they demonetized his channel for hate speech. And I'm just like, what? Wow. Because they have Muslim jihadists advocating for killing of ex-Muslims whom they consider infidels. I said, so these channels are still monetized? That's perfectly fine to advocate killing of a Muslim who became a Christian. That's perfectly fine by YouTube standards. But then they shut down, they didn't shut down his channel altogether yet, but they sent him kind of a similar nasty letter with no specifics about what he specifically said that was offensive.
Wow.
And I'm like, well, I can't imagine that he said anything as offensive as killing another person just because they deconverted from one particular faith. But that's okay with YouTube for the Muslims. And he said there's just a move. So what happened in my case is still mysterious. There was no explanation as to how it happened. I think there might have been an Autobot, and then there might have been people just constantly pressing the report button. And some YouTube administrator said, well, this is too much trouble. Let's just axe the channel. I only had 17 subscribers. My chemistry lectures had 3 views, and they shut me down.
Crazy. They got disturbed with your channel with just that number of subscribers. That's crazy. That's unbelievable.
So where was I headed? Oh, I was talking about Duke University. They charge over $250,000 to do something like gender studies. And I was just going to highlight the kind of garbage that passes peer review. And 3 professors said, this is just terrible what's happening. They put, they said, we're just gonna make up stuff and see if it passes peer review in that discipline. And they were getting in quote unquote prestigious social science journals. It's utter garbage. So I might cover that tomorrow. I mean, they're talking about why the field of physics and cosmology and astronomy needs to have more gender awareness and through interpretive dance. It was just hilarious. And so, just a little levity. So where I was headed with this, I can support your channel, and thank you for saying for our agreement that I can rebroadcast it on my channel. So what I could do is I could first broadcast it on your channel, and then I'll broadcast it on mine. And hopefully, because people will get to hear it first on your channel, mine will just be like, later.
Yes, I have an article here about the peer review of flawed process at the heart of science and journals. And I mean, what we still see is some people, they are so focused on thinking that science papers, they are proclaiming the absolute truth and that there is no errors. And there are people which think that someone having a PhD is a grant that person knows what it's talking about. And anyone that doesn't have a degree is considered as less authoritative. And I think these are very flawed concepts. We need to be skeptics about. I mean, I am skeptic about everything that I read in science papers, and we have to make a distinguishing between what they actually elucidate in regards of mechanisms that are seen when we are talking about biology or biochemistry. When, let's say, a science paper writes about the ribosome, how it works, how it's assembled together, and so forth. Okay, so there is not much room to say something which is not adequate. But when they are writing, oh, this thing evolved, and then you have to ask yourself, well, how do they know this? how do they know that it evolved? You know, and you see that is underlying in all, basically in all the biology science literature. And that's where I say we have to be skeptic about this, because many of these um, how can I say, implicit statements, they are not based on what we know. They are just based on the philosophical framework upon which the biological sciences rest, which is evolution.
Well, if we're going to try to do daily shows, maybe they should be short. We'd probably wear ourselves out and the audience if we had shows longer than an hour. I think the short ones, I don't know how Speed of Sound does it, where they're just sitting there for 3 hours at a time, just bashing creationists. I don't. Even though I would totally enjoy hanging out with you for 3 hours every day, Angelo, I'm not going to get anything done. I'd like to.
We can stop the stream after 10 in an hour total. Now it's 40 minutes, so in maximum 20 minutes we stop it. And especially if you have something else to do right now, so just let me know and we can close it earlier. No problem.
Yeah, I think we'll be able to do daily things. We have a higher probability of it if we keep it short. And if we're not able to finish the topic, we could. That's an excuse to go on for the next day. We have another topic, and let me see. I'll advertise your channel on my channel, and if I could promote my channel a little bit, if one goes to evidenceandreasons.org, I'm really trying more to promote my website. Since I had my encounter with YouTube, I don't want to be at the mercy of YouTube, and so I'm trying to tell myself to de-emphasize my YouTube channels.
I don't know if there is a good alternative to YouTube right now. I think Vimeo is good, but they are more about you have to pay to have. I think you have to pay to upload the content there. I'm not sure, but I think YouTube has basically a monopoly. There are not many good alternatives right now.
They have a near monopoly. If you can give me moderator privileges, I could post my website address on the chat here.
I don't actually. Oh, okay. Let me put that in there. Yes, sure. I can do that. No problem. Just a minute.
So while Tangela is doing this, my website is www.evidenceandreasons.org, and from there is a link to my two YouTube channels. While Tangela is doing this, one of the YouTube channels is Evidence and Reasons for the Christian faith. The other is Evidence Reasons Academy. The Evidence Reasons Academy is where I'll be posting just mostly science lectures. I'm doing that primarily so I could relearn what I've forgotten and that I need to be up to date on and skillful at to do my professional work. So I'm giving, I'm estimating I have about 120 chemistry lectures plus general chemistry lectures plus solved homework. So that's equal to like 2 semesters of general chemistry. And then I'll move on to organic chemistry and then molecular biology. I'm working with Dr. Change Laura Tan on her molecular biology series. So the Evidence Reasons Academy is just really for serious science and nerds to better equip people. Now, there probably is a more efficient way of teaching these topics, but I'm not going to find it unless I go back through all of the material and then have a chance to think about it. Because I really do think that we could teach the essentials without having to essentially train people to be chemists and professional biologists. There's probably a way, but I haven't figured it out yet. And so as I'm giving these lectures, I'll be thinking about more efficient ways that maybe I could compress the essentials for someone that might be an IT person or like Jungle Jargon, someone who's a aviation mechanic, to be able to retrain someone in these areas, just so they could understand the literature, that they could probably go through, and read peer-reviewed papers without getting intimidated. And Dr. Gart had a very kind word. He said, "Sal, that is a terrific service." Thank you, Dr. Gart. And that's what I may be doing in the coming year. It depends on my professional workload. As my professional workload may go down, I may have more time for this, and if it goes up, we'll see. So for those who don't know, my contract work is with Dr. John Sanford, and he also details me out to various other laboratories around the country. And the contract was winding down, but he seems to be wanting more work from me of late. And I had a conversation with him on protein biology today. And so I just don't know where that's going. But on the other hand, I have to be better at the chemistry than where I'm at if I'm going to continue to advance. For those that don't know my background, I was in the aerospace and defense industry. And so that was a real almost not quite 180 to go into biology. And I remember my conversation with Dr. Sanford in 2014. I said, "I don't know anything about," he said, "You're hired." But I said, "I don't know anything about biology." He said, "Don't worry, you're fine. You have the right skill sets." So, because he wanted engineers on his research team. And he said, he sent me to the NIH to learn biology and at the FAES graduate school. So I'm having to just try to keep my knowledge current. And part of that, one way to learn is to teach.
Yeah, I think if someone comes from an engineering background, and it is also my background, I'm a machine designer, then this helps tremendously to understand what happens in biochemistry, because what we see has analogy to what we make. And the manufacturing process has analogy and it has similarities. So that helps us a lot to understand these things. And I think when you understand that intelligence is required to have a machine made for a specific purpose because you have worked in that field, then that helps tremendously to understand that the same happens in biology, and that if you have not a purpose from the beginning, then there is no way that unguided events could actually construct so complex mechanisms and machines that we see in biology. And yeah.
I just found out Dr. Gart was very kind. He was responding to some of my comments. He said, "I taught there." He taught at my school. He taught at my school. The NIH has an unaccredited school that's probably one of the most respected unaccredited schools. The professors that teach there are often the researchers, and they give some of the latest. Oh, there it is. I taught environment biology and health science. Thank you. Thank you. Thank you for sharing that. Yes, it's a wonderful environment. I highly recommend anyone to go there. They created the school to help. There are a lot of people that are like, say, physicists, mathematicians, computer scientists, engineers that end up being recruited to be part of the research teams at the NIH to do biology, medical research. And so some of them have no biology background, but they need to get retrained and retrained quickly. So that school there met a need. But because it's taught by a lot of the researchers, it's very well respected. Some of my classmates were Johns Hopkins PhDs getting credit there. And it's kind of strange to be in some of the classes that might be considered somewhat basic. A lot of my classmates were postdoctoral fellows already in their field. It was just a strange feeling. So it's a pleasure meeting you, Dr. Gart, and it's a pleasure meeting someone who is a faculty member at my school. I'm very proud of that school. They don't have a lot of courses, but I've learned a lot, and it's just a great climate to be there. Very encouraging and supportive, and very affordable for someone who just wants to learn.
So did you have actually already some direct interaction with Sal?
No, never. Only through the internet. And I've heard of him through you, and I saw him in his debate with Erica, you, and John Maddox. but I was very impressed. I heard about him through Joshua Swamidas, who highlighted his Christian testimony, and I was very moved to hear it. So,
So I think we should set up a conversation like I had on my channel between Sai and Dimitar. So you two can have some chats in regards of the topics that we love to talk about.
And even beyond that, just talking about science, I respect people who are biochemists, and especially in the medical field. I just want to, now that I'm having to work with biochemists, even though my boss is a geneticist, he is very open-minded. He had me work with biochemists and molecular biologists to be my mentors. And in the process, I just had tremendous respect. My respect for the discipline grew. So yes, Dr. Gart said the students were fantastic, really hard workers. Yes, these are postdoctoral students going back to sometimes be taking undergraduate classes. So it's just a great environment. 30,000 people there on the NIH campus and connected campuses just trying to advance medical research. It's just exciting to be there. So, perhaps we could meet tomorrow. I can talk about a totally light topic. It's not really focused on biology, but it's something that I wanted to talk about. Some of my concern of what's happening in academia, and then also why I'm interested in finding alternative means for educating people, partly because of my experience at that school that Dr. Gart taught at. It was affordable and the quality of education was good. And then I contrast that with what I see happening in certain other places, other pockets of academia. And thankfully, I got my degrees when it was still affordable. I couldn't imagine trying to go back to school now. So with that, thank you for having me on your show.
Yeah.
And
okay. I thank you, Sal, for coming to my channel. And after we finish and end the broadcast, we can set up eventually a topic for tomorrow and see how it goes and how we can continue this. Okay, so thank you to everyone which has assisted our stream tonight. I hope I'll see you tomorrow again, and we'll set up something with Sal. And if you want to participate and join our conversations, feel free to do so. So have a good night, everyone. See you next time. Bye-bye.